In our last class, we have seen the forward difference. So we have done this. As you can see, the forward difference, this was the formula. In the forward difference, we used y naught, that is initial value. We use del y naught, which is the first difference. This value, this del y naught, this initial values we do. Now we are going to see the backward difference. In the backward difference also, you will be given a set of data points in form of x and y. You can either find out the value of a particular value inside these data sets of x and x naught and xn, then it is interpolation. If it is beyond this x naught and xn, then it is extrapolation. The formula for Newton backward difference interpolation is this. This is the formula. As you can see, in backward difference, we are using yn, that is the last value. But in case of in forward difference, we are using y naught, which is the initial value. Similarly, in backward difference, we are using the del yn, which is the last value, the last difference value. But in case of forward difference, we are using del y naught, is the forward, the first initial. So keep that in mind. Do not confuse them. Also, with respect to p, the formula for p in case of the forward difference formula was x minus x naught by h. This was forward difference. But in the case of backward difference, is x minus xn. Pay attention, it is xn. So in backward difference, everything is with respect to n only. It is yn is backward difference of yn and y. So keep that in mind. Just like the forward difference table, we also have to make the backward difference table. As you can see it over here, have to make the backward difference table. In the backward difference table, the last value, it is your yn, this is your yn, and these are the values that you will be using. These are the values which you will be using in your formula, this particular formula. As you can see, it is equals to yn, isn't it? Now, generally you can use any method for any type of problem, but it is preferable that if your x value is near to the x naught, then use forward difference. If it is near to xn, then use backward difference. If it is in the middle, then use center difference. But this is not a hard and fast rule. You can use any of the method or as given by the instructor in your question paper. Now let's see an example. In this example, you are asked to find out f of 32. The data set which you are given is from 20 to 45, isn't it? So f of 32, it lies between 20 and 45, so it is an interpolation. So for 20 you have this value, for 25 you have this value, and so on. Now, can I use forward difference formula? Yes, you can use forward difference formula, no issue. But here I have specifically asked you to do the backward interpolation. Okay, can I apply this? See, the interval is constant. What is the interval from 20 to 25? It is 5. What is the interval from 25 to 30? It is 5. 30 to 35, 5. So all of them are 5. So I can use this formula. So first we have to make the backward difference table. I have just put down the values 20 to 35. I have written in the first column. In the second column, I have written the corresponding f of x values. As you can see, the last value is 45 for x. It is your xn. Similarly, the last value for f of x, which is y, it is your yn. Now start from the last and keep on continuing. From these two value you can calculate your this. From these two you can calculate your this, and so on. Keep on doing it. So you will get in your data sets. It is similar to your forward difference formula only, which we have seen in the previous class, but in the backward difference formula we are starting from the back side and we are taking the yn value, delta yn is value. In this particular formula, what is your xn? As you can see, it is 45. What is your 8? It is 5. Then how can you calculate p? Yes. Now you can either keep them as x, keep this as x, or directly put out the values. From where you will get this x? This is the push. In the question you have been asked to find out at 32 value, isn't it? This is your unknown x value, so just put that x over here and you can calculate your p. Once you know your p, this is your basic formula, forward difference, backward difference formula. Here, first value is y of n. What is your y of n? Last value. Over here, it is this. This is your y of n. So just put your y over here. Now P you have already calculated. Del y of n, this is from this first difference formula, the last value which you are calculating, this is your this is basically 104. It is sorry, 204 minus 231 231 231. These two values, 204 minus 231. So this is 27. So this is your this first value. This first value. Now what is del square? When this is your from the second value, this from second value. Then this 3, this is your this third value, which is basically it is 0. Since it is 0, so I have in the next step I directly going to 0. So just go through it. It is very easy. Put down the values and calculate yourself. The only thing which you need to pay attention is that in the forward difference formula, as you can see over here, we had y naught, del y naught. We took them, these are initial values. These values we took this forward difference. In the backward difference, we took the backward values. Started from here, we took these values. So that is the only difference. Thank you.